Good morning, everybody. I'm Chase Norton, head of AI here at Faros. Thank you so much for joining us today. This is the third conversation in a series. Today, we're going to be talking about smart routing isn't enough, why AI coding needs proof, not prediction. Before we get started, let's go into just some housekeeping. This session will be recorded with the slides, and they are going to be put up on YouTube. So I encourage you, as you listen to this, be immersed, be a part of it. Don't worry about taking notes; those will be up there. But also, as we kind of go through, write down any questions that you have, or there is a box that you can put them into. And at the end, we have some time that we can kind of go through those. So feel free to just kind of sit back, be a part of this, be immersed as we start talking about why smart routing isn't enough and how we can start to build a framework to think about the bigger picture, the bigger system itself. As I said, I'm Chase, head of AI here at Faros. Background in entrepreneurship, in AI, machine learning, product engineering, the entire gambit. At Faros, my job is kind of to work across different pillars, and so helping to bring AI wherever I can and to grow it and mature it across the org. If you weren't able to join us for the first two parts, let's just quickly go over those. Part one was looking at how can I understand my spend? How can I start to observe where is my AI usage spend going, and kind of shedding a light onto that. In the part two, we looked at now once we understand the spend, how can we actually connect the AI usage to outcomes? How can we connect it to things that the company cares about? The strategic initiatives, what leadership is looking at, and so that we can start to tie that story from the AI usage that an engineer is doing all the way to what is actually moving the needle in the company. But that brings us to part three. So, where we're going to be looking at today is once we're able to tell the story of AI sessions to engineering outcomes, how can we start to think about the optimization of that? How can we start to provide suggestions for optimization, but also govern the entire system? And in the industry right now, we are hearing a lot about routers. We're hearing a lot about smart routers, dynamic routers, and this plays a role, but really it's about understanding the entire system. So it's about saying, as my engineers produce outcomes, was there a more efficient way to do that? Was there a different model, a different harness? But also looking at it from the individual, how AI mature is this individual engineer? And then what can we do to start to not just optimize for the router or the harness, changing the models, but the entire system? Can we apply policies? Can we modify skills? Can we modify the harness and the model? All of these come into something that we have for token engineering in our platform that allows for you to really take that engineer, take that AI session, and start to not just produce the outcomes, but then optimize so that those outcomes become more efficient over time. One of the biggest differences between the way routers are today and at least the approach that we take in Faros and kind of the framework that you can walk away with is evidence has to change behavior. It is not simply at the point of routing, at the point of execution that matters. It is also looking at it from if we were to look back at all of these sessions. So again, if we have AI usage that's connected to a PR, that's connected to a Jira task, we now have that as not just a story, but we're able to say, this is actually what happened. What if we start to change things? What if we start to ask what if questions of looking at the actual evidence and then running different modeled scenarios on that evidence to figure out inefficiencies, to figure out where we can actually make change? And one of the things that people are asking most, especially leaders, is once I can understand that story, I can start to understand where to invest, where to standardize, what to guardrail. Once you can have the understanding of the outcomes, you can start to actually look at modeling ROI. You can look at which engineers are AI mature, which ones, where do I want to put more money into AI that's working for the repos, the teams. Where can I start to look at the skills that either aren't working or are not there and start to standardize around certain practices and also guardrails. And so this comes to this idea of AI maturity, which is kind of just this term of in our company right now, no single engineer is the same in how they use AI. AI is this fascinating thing that we've all kind of learned independently and now are applying at scale inside of enterprise and inside of companies. But that means that you're going to have some that are, let's say, resistant-ish. You have some that are just beginning. You have some that are wanting to learn, but maybe not very comfortable. And then you have all the way up to no-code users that are extremely AI mature and very proficient with the tools. All of this spectrum requires a different approach per engineer, per repo, per team, in order to begin to understand how to make them most efficient and optimize the usage coming from that engineer. And sometimes it's not even about a policy or a code change. Sometimes it's even just about having the awareness in your company, being able to take a very mature AI engineer and mentor to a less mature engineer. So it's a human element as well as a systems problem as well. And so as we go through this, it's not just the same work. You have different teams, different engineers, different repos, tasks. And then also as we get into this, as I said, like the router is just one aspect, right? That one point at which all the traffic is going to flow out through, but it's also the context. So as an engineer is using AI, do they have context bloat? Do they have the right agents.md file? Do they have the context necessary in order to accomplish their goal? Are they using the right skills? Are they going through the right workflows? And do they have the right policies associated with their flow? And really, when I say policies, what I mean is, at least inside of Pharos, you can think about it as we have the stream of AI data coming in. This is nowadays known as the AI SDLC, but it's bringing those AI sessions into the traditional SDLC that we know. Once we're able to make those attributions and we're able to tell the story of this session is connected to this work that's connected to this outcome, then you can begin to optimize around that, right? You can begin to tell the what ifs. Once you find where those inefficiencies are, you can then apply policies. And here at Pharos, we have a gateway that all of our AI traffic goes through that has a router inside of it. And those policies, those inefficiencies can actually be applied at the router level so that you have, as time goes on, more AI sessions flowing in, more what if scenarios run, more inefficiencies found, or hopefully less, but inefficiencies found, more suggestions, and then more policy changes. And you can tell the loop starts to close, right? You start to get this closed loop of learning as you start to modify and measure and optimize all the different components here. So it's not just one control, it's context. What if we change the agents.md file to include X, Y, and Z? What if we evaluate it for large context and model it versus small context bloat? What if we see repeat patterns, right, across PR reviews, for instance? Many engineers do a lot of PR reviews. And are they doing it ad hoc? And so they're all doing it differently. Is there a way that we can consolidate around a specific workflow? And so this really gets into not every AI problem is a routing problem. It is thinking about it in terms of the system and whether or not you want to think about it as the AI SDLC or you want to think about it as just the entire system. It is about as the data flows in, what is the different inefficiencies that exist and how can we optimize for them? The router itself, it may see just one execution, right? And so at that one endpoint that exists, there may be the request, the session, and this is really all that it sees. It sees the one snapshot of data that is flowing through. And this is why, when we think about it, right now, a lot of focus is being put on that one individual endpoint, that one individual moment. However, there is the larger system that is going on. We have looking at not just like the outcomes, not just the maturity, but it's ROI. It's all the different components that go into what are we actually trying to optimize. And the router itself sees one snapshot of that overall optimization. When we get into kind of the what if scenarios, right? First, the very first thing that we have to do, and we're going to kind of get into something that we did here in Pharos that can kind of apply more generally. But one of the things that we first do is we have to diagnose, right? So as the data is flowing in, we have to be able to say these what if scenarios allow us to identify all the different inefficiencies that I've mentioned. So was the agent having a lot of failures on tool usage? What did the PR get closed well, or were there a lot of reviews in it? What is the overall context size? And even session length goes into it. So the very first thing is once we have that attribution, being able to tell ourselves, okay, we need to be able to diagnose what the problem is, and multiple problems normally before we even begin to say, let me try to just optimize at the router point, right? Looking at it from that holistic view. And so that's one of the things that we did here in Pharos. We said, okay, we had 211 tasks. You can think about task as a PR. It's not exactly that, but you can think about it as that, which is engineering work. So if we were to take these 211 tasks and run them across many of our different harnesses, our models, different scenarios, what is the outcome? Is it actually that we should be using frontier models? We should be using Opus 5? We should be using Fable? Or is there, as we actually run these scenarios and we take these 211 tasks and we roll them back and then play them forward, is there something that gets revealed? And it turns out that the thing that got revealed is within certain code bases, we had open weight models, GLM 5.2 especially, and different open source harnesses that perform better than frontier models. Pretty aha moment for us, at least. And so once we started to identify that, we said, okay, at the or at the router level now, what if we start to route into these different harnesses, the GLM 5.2 for the model, open code for the harness itself. And so inside of Pharos, we ran that study. And what we found is that not only were we able to achieve our same outcomes, but we were able to do it at about 80% cheaper, 78% cheaper. This is one of the biggest aha moments that we had inside of Pharos for how we can start to actually not just manage, but have the insights into and control over the spend, the outcomes, the understanding of efficiency, this kind of movement as the data flowed through. And so very important to kind of think about it from as you start to have these PRs and these tasks, and you start to roll them back, and you start to ask the questions, you start to model, what does it start to say? And it's different per team, different per engineer, different per company. And so this is why it's important to say like each element that you want to study, whether or not it's the level of granularity, whether or not it's the engineer, it's the team, or whatnot, each one has its different way to optimize. For us, we found modifying the model and harness, but we also found that there was a significant number of very long, multi-week long sessions that we were able to identify, talk to our engineers about, figure out why are they having these sessions. And sometimes it's justified, sometimes it's education. And the other aspect of it is we're able to analyze across skills. So there's this thought or understanding of like a skill tool set that companies now have. These skills we were able to identify with PR reviews. We were able to understand it based on per repo. Different repos had different continual patterns, whether or not it was infra monitoring, it was deployment monitoring is a common one. And so building out those skills helped to also reduce us down to this number that you're seeing here. So the whole picture there, rolling back those 211 tasks, looking at the different inefficiencies, applying it both at the router level, the human to human engineer level, the agent skills, the context environment all come in to play here. When we're looking at it, one of the things that kind of a 2024 ideal was this token maxing or token leaderboards, right? And we have kind of pulled back since then as the costs have kind of ballooned and we were all dealing with how do we actually adopt this technology without it blowing up the budget and without it making uh, the finance team go crazy, and also so that we can make sure the longevity of this tool and the use of it is something that is matured and brought into enterprise in a way that 5, 10 years from now, we're all using it in a way that drives what the company needs. It's kind of fascinating because if you think about it right now, we are year 4 into understanding AI, LLMs within like this workflow, this process. Every year kind of has a different milestone, right? 2022, 3 was really about being in the browser, being in ChatGPT. We started to see Cursor come about then, right? And so we started to have this vision of using it in an IDE. Along that time, Sonnet came out, Sonnet 3.5, and that allowed for the term that you now see of like vibe coding and whatnot. And around that time is when enterprises started to adopt it. And that was only about 2 years ago, right? And so we're at this phase, and then it was token maxing, and now we're at this phase of trying to outcome max or get the outcomes that you really desire for the best spend possible, right? And so I say this because right now at year 4, it's understanding we are the stewards of the future. We are setting not just the direction, but also we are setting the groundwork and the framework for how we will work in the future. We'll look back 10 years from now and realize that these were the moments we were kind of not stumbling around, but figuring it out together. And so I think that's so important why you're here right now, why we're kind of talking about this, why we continue to have these webinars is more community involvement, more discussion, more thought leadership around this kind of topic, I think is critical, and really every single topic in the field right now. So as we look here, cost and quality don't diagnose themselves. And really what this is saying is you can have a high spending AI engineer. That's not really the problem, right? At some cap, it may be the problem, but really the we want to make sure that that high spend is connected to outcomes. And as long as I think we'll all agree, if we had an engineer that spent $1 million today but produced an app that made us $10 million tomorrow, that's fine, right? It's not so much the spend until, there is some kind of budgetary concerns, but it's really connecting, is this AI usage actually driving outcomes? Is there a way to, even though it's driving outcomes, produce the same quality of work, but more efficiently? It's all that kind of understanding, right? You can have kind of the 2 by 2 of an AI engineer who is spending a lot, producing a lot, that's great. Spending a lot, not producing a lot, not great at all. But even down to not spending a lot, but producing a lot, right? We want to understand those scenarios. We want to understand those engineers because really there's an unlock there. What are they doing different? Is it that they're opening up new sessions every single time? Is it that they often defer to Sonnet or maybe even Haiku or doing Terra and Codex instead of always Sol? What is the reason behind that? And gaining that insight is a huge unlock for low AI usage, high outcomes, where the outcomes are tied still to AI. It is a low spend AI usage. So I say that to say, as you kind of think about this, it's not so much of like one thing is the problem, but it's inside of the entire view that we need to look at it. So as we go through this, one of the things that routers do is as the prompts are coming in, it makes a decision of do I go left, do I go right, do I go with this model? It makes it kind of in the moment. However, the intervention or the optimization fix is really about understanding the failure mode. And that is, I don't want to say rarely, but it is only one piece, which is the harness and model and being able to route to the right model. It's really looking at it from what I've been trying to say, the entire scope where the optimization fix that goes in must match the failures that we're seeing in the company. Just simply switching models will not get you to the point of having the efficient outcomes that you're desiring. And so it's much more about understanding the actual problems that are going on, and then what are those interventions? How can we apply them? How can we have understanding into them? And so, in that framework of like, as you're thinking about this, connecting what actually is the problem? Is the problem that the models we're using are just not are not the most efficient models? Maybe sometimes, but looking at it from like, I want to see all the issues that are going on, and then being able to apply the correct fixes for those. And so this is where a local win is a hypothesis. And so when we're looking at that specific router, it is that one engineer, that one instance, right? But there is this way of looking at it more from the entire loop, the entire system. As I've been saying, if you have one engineer, one router, one win there, it's not going to get the company to the point of being able to have the overall efficient wins. And so really what we want to do is we want to look at this from the loop, right? The entire engineering loop, AI engineering loop that is possible. And so as you have data flowing in, then you have analysis of that data, attribution connecting it to work, and then the overall diagnosis of what's going on. Diagnosis then gets applied into different policies and different things. Those policies then get applied at a router level, but they also get applied at the human level. They get applied at the skill tool set level. They get applied in multiple different ways, and then the loop continues, right? And so you're able to start to actually optimize the entire engineering org, not just a single engineer, not just a local instance of a problem, but the entire engineering org, or you can look at it from the org, the team, at some level of uh, aggregation, you're able to start to optimize for that grouping. And I think that this is the framework in which, like moving forward, thinking about it more than just the router itself. And so here, diagnose to intervene, again, the route, the context, the skill, the workflow, the policies, all of this to prove, keep, narrow, revert. The loop itself of after you apply them, evaluate, are things getting better? Is the system getting better? Do we need to apply different policies? The idea is hopefully that you spend less, your outcomes get more, your engineers grow in terms of their AI maturity and adoption, and this loop gets tighter and tighter. And so as we're thinking about it, routing is one control, the loop is the system itself. And so throughout this, as we go through the part one, part two, and part three, we're looking at it from this idea of the loop. We're looking at it from really a token engineering platform. However you want to think about it, it is the idea that routing itself is one part. And I think that there is a lot of directions to go for exploring optimal routing or efficient routing. If we step back and we look at, we've for years have had, I mean, always have had the software development lifecycle, our SDLC. How many PRs are being opened? How quickly are they being merged in? What is the efficiency of my engineers? And we can take that same kind of framework and concept and bring in AI into it and now look at it from not just the router, the model, what is the one thing that I need to do, but understand that AI is impacting everything. It is in every single workflow that we now have. And so it's not just one single point. And also to understand that like so much of AI today is a human, I don't want to say problem, but it's a human process. And it is very, very personal. It's very, like I said, we all learned it together or individually. And so understanding that as we take this journey of getting to be as efficient as possible, some of it is at the router, some of it is at the policy, but a lot of it is actually just coming together like this, having conversations, being able to sit down with engineers where we see issues or we see inefficiencies, we see high spend, have a conversation and be able to bring that back in. So routing is one control, the loop is the system, and that loop includes both human and AI. I want to thank everybody for coming here today. We have a few more minutes left for questions. Before we dive into questions, I just want to go over if you want to know more, if you are interested in kind of going deeper into this, we have what is changing in AI engineering, the acceleration whiplash goes into a lot of impact that of how AI is impacting PRs, code growth, and many other aspects of engineering with AI today. Highly recommend it. Please scan that. We also have how to measure productive AI work, the field guide to token efficiency. Both of these are takeaways that you can download, bring to your team, read through, and I would highly encourage that. Going back to questions, looks like we have one here. Actually, two. Okay. How do you determine whether a poor outcome came from the model choice versus missing context or a broken workflow? Phenomenal question. And I think this is where looking at it not from just a single point of failure, but looking at it from if I can understand how this AI usage got connected to this actual output, this work, these outcomes, those the ability to say like what is the problem, right? Or what is the inefficiency is something that you can actually start to model. So you ask here came from model choice. Perfect. We can roll that back and we can play it forward with a different model. Does the outcomes meet the ones that the original outcomes? How efficient is it? What is the spin like with this other model? So you're able to play that forward. Missing context, same thing, right? We can roll it back, we can remove the context, we can roll it forward, we can modify the context and roll it forward. And lastly, broken workflows. So we can understand if you within your org, if you unlock OTel data and you are able to actually send OTel data from your harness, you're going to have this rich, deep amount of data that tells you tool failures, how many times did it call for X, Y, and Z? What was the overall multi-sub agent team that was kind of spawned from it? You can tell a lot about a session from that data. And so from that, you can understand, is there a workflow that's broken here? Do we have agents that are continually trying to do a certain task and failing at it? So all of these things, it's not so much about looking at it from one lens, but if you are wanting to know the entire picture, it's about having multiple of those rollback sessions and play forward sessions. Internally, or here at Faros, we call it the time machine, but it is this idea of being able to take a outcome and then model different scenarios of that outcome. And many of these are the model choice, the harness choice, missing context, broken workflows, everything that you brought up today. The last question, when a routing experiment works for one team, what evidence do you need before making it a company-wide policy? Yeah, good question. The I would encourage that as we begin in this journey of optimization together, right? And by together, I mean the industry, right? As we're kind of beginning into the 2026 journey of optimization, moving definitely into 2027 and beyond, it's not so much about like when can I make it a company policy. It may not be necessary to make it a company policy, right? Each engineer is different, each repo is different, each team is different, but it is starting to understand like where are your scopes, where are your groups that you can create, and I think a great place to start is at the team level, maybe at the repo level, but starting there to see what inefficiencies exist, what policies can I apply. And then you're going to start to notice patterns around teams, right? And as you start to notice those patterns, you can roll those up into the org level so that you can then apply it at a higher, kind of a larger scope level. And then just keep rolling it up until all of a sudden you have this is our company-wide skill sets, this is our company-wide router policies, but starting more at the team or team repo level, and then allowing that to reveal what the commonalities are. I think is the unlock there. So both great questions. All right. I think that allows us to come to the end here. Again, thank you for joining. So much of this right now is about us talking, right? It's about us sharing. It's about being in the moment and being present and being able to have these conversations and figure it out together. We're trying our best here at Faros, of course. We have many different paths and directions that we're going, but also having it with the community. And so please reach out on LinkedIn, check out our go to our website, and please, if you're interested, sign up for a demo, contact our team. We'd love to get in contact with you. But reach out and join the conversation is the biggest advice I can have throughout this entire series is be a part of the conversation. So with that, I'll say thank you so much for joining. I look forward to seeing you on the next one, and I hope you have a great rest of your day. Thanks so much.